This is a second solution where we're solving this problem. This requires a bit of trigonometry to solve, and is, well, you just have to understand it to solve it. So this is still the unit circle, right? And, well, what we can know is that each vertex, well, it obviously varies. And well, you can simply use one of many trigonometric formulas to find out that each one has a unique length of e to the power of 2 pi times I times k over 7, for k is equal to 1 to 6. Values in between 1 to 6 inclusive. So, why is this true? Because at a vertex there are 6 points jutting out to all the other 6 points on there. They have 3 of them have same lengths, 3 of them have different lengths, and since we're talking in terms of trigonometry as e to the power of I times pi is sine of theta or sine of a function, we can now know that this is the sine of a function. So we have that down, right? And therefore, the distance between 2 points, call it d, is the absolute value of e 2 pi I k over 7 minus e to the power of 2 pi I, another variable, j over 7. Now, what this means is that these are 2 different respective points with different variables as it represents different points, but that's just that distance or any of those distances. So we have this. Now if we use Euler's formula, which states that e to the power of I pi is equal to sine of theta plus the cosine of theta, we can then do something, it's called factoring. D is equal to absolute value of e to the power of 2 pi I j over 7, but this is when j is in front, so should reverse that to make it more clear. And then this inside is 1 minus e to the 2 pi I times k minus j, all over 7. It's gonna be hard to read. This is division by 7. You see there. Now we can write it in simpler terms with trigonometry. D is 2 times the sine of, or no, that's the next step. D is equal to the absolute value of 1 minus e to the power of 2 pi I m over 7, where m is equal to k minus j. We have that. So now d is equal to 2, that's the inside. So we just write it like that. 2 times the absolute value of sine of pi m over 7. Okay. We have the distance here. The problem states we want it to the 4th power. So we do d to the 4th power is 2 absolute value sine of pi m over 7 to the 4th power. This here is simply the absolute value of 6 sine to the 4th power of pi m over 7. Now we have a few sine angles that work. There's 2 sine of pi over 7, 2 sine 2 pi over 7, and 2 sine 3 pi over 7. Any one of those over is going to be a repeat of itself. And, well, basically, you want to sum all of these up in a way where you can use the formula you take the fourth power of this and multiply 7 and 2 to the fourth power that we were missing, as it's a unit circle, so the radius is 2, diameter is 2. So our answer is going to be 7 times 16 times sine to the fourth power of pi over 7 plus sine to the fourth power of 2 pi over 7 plus sine to the fourth power of 3 pi over 7, right? And, well, simplifying this all down, what we get is, 7 times 16 times all this together. You can either deduce by answer choices or just multiply this out, that our answer is 147 by calculations.